In the last video, we looked at why displacement and distance are related but different values that we need to find. And if you are feeling confused about the difference between displacement and distance, you should take a look at the last video for problem 17. In this video, we're going to just compute the value for displacement. So we're still looking at the same equation, same function. V of t equals 36 minus 24t plus 3t squared meters per second. And if we're looking for displacement, we want to know where the particle ends up at the end of 10 seconds. So when we're looking at displacement, we're thinking about taking the integral, and the integral will automatically take care of the fact that we have a negative area between 2 and 6. And remember from last time that we figured out where that area was going to be negative by finding the zeros of our function, which we found at 2 and at 6, and then determining where the function was going to take on positive values, which would be between 0 and 2, and between 6 and 10, and where it was going to take on negative values, which was between 2 and 6. And if we look at the graph of our v of t function, we'll see that the graph dips below the t-axis between 2 and 6. So it's going to have a negative area, a negative signed area between 2 and 6. But we don't have to worry about that when just finding displacement, because taking the integral automatically takes care of where the area is, if it's positive and above the horizontal axis or negative and below. So we can straight up just take the integral if we're finding displacement. So let's go ahead and do that. So we're looking for displacement right now, which means that we want to find where this particle finally lands, not how far it's traveled, but where it ends up, its position at the end of 10 seconds. So we're just going to take the integral from 0 to 10 of our original function, 36 minus 24t plus 3t squared dt. When you integrate that function, you end up with 36t minus 12t squared plus t cubed. And then we'll go ahead and evaluate that from 0 to 10. When you plug in 10 for t, and plug in 0 for t, so that should be squared, you will end up with 160 meters as your displacement. You can check that by using the integration function on your calculator. Your limits of integration are 0 and 10, and you should come up with 160 meters. In the next video, I am going to compute distance, which will give us not where the particle lands, but how far the particle has traveled.